This is a tutorial for the projectile motion simulation. I'm going to click on it here, and it opens up to this screen. And the first thing you can do is you can click this green button and it fires the projectile, which will land, and it will give you the range of the projectile based on this speed here, which you can adjust from 0 up to 50 in increments of 2, and the angle, which you can adjust from -30 if you're on a hill, up to, of course, 90 degrees. And you can see that the range is actually changing based on those parameters. If you click this, it resets the ball, which will remove the final results. You have a couple of options as well. You can actually zoom out and zoom in as you need. And you can adjust the simulation speed to be faster or slower, which I'll show you a couple options why you might want that. You'll also notice these points here that are glowing. So this allows you to fire the projectile up onto a cliff, for example, or raise the cannon up and fire it downwards up onto something below, for example. So you can set up your simulation to do that. And if you hover over to the left here, there's a bunch of options. Info will give you sort of frame by frame, I'll click reset, updated information on the time of flight, the DX and the DY from its initial launch point. I'll remove that for now. Velocity will show you, if we hit reset, it will show you the velocity vector diagram. It will not change size as you change the speeds. I just made it a comfortable size, a uniform size, but you can see it will change as you change the angle. And if I'm first introducing projectiles, I might, for example, slow down the simulation and fire it so the kids can see that the horizontal 14.1 remains constant, while the vertical 6 point whatever it is slowing down and then speeding up again. You can see we're zoomed out quite a lot. So if you don't like the zoom, you can hit the reset button down here and it will zoom it back to a comfortable level. It still may need to zoom out. Okay. Going back in here, if we select trajectory, I'll unselect velocity, it will show you the parabolic trajectory. And so you can set this up as you would like. Okay. Routes will show the actual routes before you fire the projectile. Sometimes I might do this to show the kids that if it's firing from a higher level, you're going to get that negative route as well as the positive route. Whereas if you fire it up onto, let me increase the speed, if you fire it up onto a platform, you'll get 2 positive routes, for example. The monkey, this simulates the monkey and hunter. So if you click this button, it's probably a good idea to get rid of trajectory and to reset and get that hill back down. And you can speak to your kids about the monkey letting go of the branch the instant he sees the hunter pull the trigger, or if you change it into the zoo feeder, throwing bananas at the monkey, whatever you like. But you can hit fire, and of course you can see the monkey fall directly into the path of the baseball. That's monkey and hunter. Rifle, what I did here was I programmed a semi-realistic speed for rifle bullets, 700 meters per second. And this is, at least so far, in the absence of air resistance. I like to also put the trajectory on, and when you fire it, I like to kind of ask the kids, would it clear the CN tower? Which you're going to see here, which of course it would in the absence of air resistance. And sometimes I might even speed this up. So, there's the Burj Khalifa. And it keeps going. You could ask the kids, will the bullet clear Mount Everest? Which it easily does as long as there's no wind or air resistance. And we'll let it keep going. This does take a while, which is why I increased the simulation speed to 300%. And if you let it keep going, actually, you know what? I won't let it keep going. You guys can find that out yourself. There's one more surprise at the end there. I'll reset the simulation. Finally, I have an option to include air drag. Now, I did not incorporate this with a physics equation. I just did a simple kind of exponential decrease in energy every time. So this is not simulating real drag, but if I increase the drag, you can at least see that the bullet will not follow the pink trajectory. You can see that it's starting to fall short, and it will actually fall far short of where it would actually land. Perhaps you might want to show drag not in the rifle context, so you could just sort of fire it in a regular parabola to see that it actually lands short of its target. And that is the projectile motion simulation. I hope you enjoy.